The last shape that we're going to talk about in this unit is a regular polygon. So remember, a regular polygon is a polygon, pentagon, hexagon, octagon, decagon, those kinds of shapes that have equal sides, congruent sides, and congruent angles. So we're going to look at how to find the area of those, and they get their own formula. Quick review, central angles of regular polygons, because one of the important things that we're going to do is we're going to be able to break this into pieces, because sometimes we're going to need that central angle. Now, it's a central angle of a polygon because technically we could draw that circle and it could be inscribed in that circle. And so it is the central angle, right? That's the central angle of that circle. And so it's also the central angle of the regular polygon. Now, it's a five-sided figure. And so since it's a five-sided figure and it has 360 degrees inside that circle, I can take and find out that the central angle is 72. So each of these angles is 72. Okay, with this hexagon, again, I find the center. Imagine that there's a circle drawn around this. Then each of those would also be the central angle of that circle. It's 360 divided by 6, and you would get that each of these angles in the center are 60. Now, ultimately, what we're going to care about is one of those little triangles. And then we have this octagon. So one central angle would be 360 divided by 8. So that would be 45. So each of these is 45 all the way around. Okay, so if you are asked to find the central angle of the shape, you take 360. So it's 360 divided by the number of sides. Now, if we take this shape and we drew a circle, if we took this hexagon right here and we drew a circle, because I want to explain why some of the vocabulary is what it is. Pretend that each of these points is on the circle. So we have some pieces of this hexagon that are important. One is called the radius. So the radius goes from the center to the vertex. Okay, now notice that it goes to the vertex of the hexagon, but it also touches the circle because the hexagon is on the circle. So since it's the radius of the circle, it's also called the radius of the polygon. Now, the other one that's really kind of a new word for you is apothem. Okay, apothem. That's how you pronounce it, apothem. Okay, the apothem goes from the center perpendicular to the side. Okay, from the center perpendicular to the side. Now, notice that the radius and the apothem and the side form this right triangle. That is going to be extremely important in some of these problems because we're going to have to find information to be able to use this formula. So the area that we use, the formula that we use to find the area of a regular polygon is that the area is equal to 1/2 of the apothem times the perimeter of the shape. Okay, A stands for apothem. Lowercase a stands for apothem, which is that little segment that goes from the center to the side, times the perimeter, which is all the sides added together of whatever shape it is. So we want to leave our answers in exact form, so let's look at this. Now, just keep in mind, you are going to, sometimes you might need to use trigs, sometimes you might need to use 30, 60, 90s. So just a quick reminder, let's come over here. Quick reminder, it's on your formula chart. And we'll figure out when to use these. But remember on your formula chart, your 30, 60, 90, that's 2x. Your short side is half as long as your hypotenuse. And your long leg is the square root of 3 times the short leg, okay? So here's why we need this. So let's look at what we have. So we have this hexagon. It's a regular hexagon, which means all of the sides are the same. And all of my sides in this case are 10. Now, in order to find the area of this polygon, what we have to use is we need 1/2 AP. So I need the apothem and I need the perimeter. Well, the perimeter I've got, that would be 60, right? Because all the sides are 10 and there are 6 sides, and so it would be that, okay? Now, to find the rest of it, here's what you need to do. We need to draw in that central angle. Okay, so we look at it like that, and then what I see is that this angle right here is 60 degrees, right? 360 divided by 6, so that's 360. Now, if that's 60, we know that these have to be equal to each other, so this is also 60, and this is also 60. Okay, so that's useful because what that tells me is that all three sides have to be the same, so now I know that the radius is 10. Okay, so my radius is 10. Now, why that is useful for me is this. You have a couple of options. You can shortcut it and use 30, 60, 90s, which is what I like, or you can also do Pythagorean theorem, and you can find it. Now, it says to leave it exact. So if you're doing Pythagorean theorem, that's where it makes it a little bit harder. That's why I think it's easier just to use 30, 60, 90 triangles. Now, when I drop down that green line, I cut that 60 in half, which means this angle is a little 30-degree angle. So you got to focus on this. So just kind of ignore the rest of the triangle for a minute and look at what's happening with this, or the hexagon, and just look at what's happening with this little yellow triangle. Well, my hypotenuse is 10. My short leg is 5. I notice that this is a 30, 60, 90 triangle. That means that my long side is the short side times the square root of 3. So my long leg would be 5 root 3. Okay, that's the apothem. So the apothem is 5 times the square root of 3. Okay, so let's kind of rehash. Right, I drew in that central angle, and that gave me this equilateral triangle, the big red triangle. Okay, that gave me this. I needed the apothem, which is basically the height of that triangle. Not basically, it is. It's the height of that little triangle. Okay, so then I needed to find out what that was. Well, I drew in that height, and so then I could use my 30, 60, 90s. Okay, and so I split that 60 in half, so it made that 30 go up in that top, and then the 60 degrees was in the bottom, which I already knew because it was an equilateral triangle. Now I have what I need to find the area of this hexagon. It's 1/2 the apothem, which was 5 root 3, times the perimeter, which is 60. Now we want to leave our answers exact, and so that square root of 3 is going to act like pi did when we were getting answers like 5 pi. So you would multiply 1/2 times 5 times 60. Well, I like to mental math it, so half of 60 is 30, and 30 times 5 is 150. So my area is 150 root 3, 150 times the square root of 3. If I asked for you to round it and get the approximate, that would be approximately 150 times the square root of 3. You would type that in on your calculator, and you would get 259.8. That is my approximate answer. My exact is 150 root 3. Okay, so that's your hexagon. Well, let's look at our triangle. You can find the area of a triangle, depending on what you have. You can find the area of a triangle also because it's equilateral, so that means it's a regular polygon, even though we're used to it. Now, you have lots of options. You can always go back to base times height, okay? Just know that. You can always go back to base times height on this, but I'm going to show you how to do this with what we have. So if I find my central angle, right, if I go in and I split this into all of its equal pieces from the center, then I have that this angle right here, the whole angle is 120. Okay, now the radius, it says that the radius is 12. Remember that the radius goes from the vertex on the center to the corner. So this is 12. That means this is 12 also. Now let's talk about what happens to the angles. So I just split that 120 in half because I need the apothem and I need the side length. Okay, so I just cut that in half. That makes that 60. That was already 90. That makes that 30. Again, go back to your right triangles. That means this is my 2x side. That means my short leg is half of my hypotenuse. So my short leg, which is across from the 60, is 6. And my long leg is 6 times the square root of 3. Okay? That also means this over here is 6 root 3. Okay, so my side lengths now are 6 root 3 plus 6 root 3, which is 12 root 3. Okay, 6 root 3 plus 6 root 3 is 12 root 3. So this is also 12 root 3. Again, I used this little triangle to find all my pieces so that I can find what I need for my big triangle. The apothem is 6. We calculated that. My side length is 12 root 3. My perimeter would be 3 12 root 3s, right? 3 times 12 root 3, which is 36 root 3. So my area is 1/2 the apothem times the perimeter. And we want to leave our answer exact. So I take half of 36, which is 18. Right? So 18 times 6 is 108. You can multiply it however you want. And you get 108 root 3. When you leave it exact, you don't multiply the square roots, you don't multiply the pies, you don't multiply any of that. Okay? So let's look at this. The radius of a square. Again, given the information that you have, you can do a lot of different things with this. You can use the equation for a rhombus. You can use the equation for a square. And you can use the equation for a regular polygon. So it says that the radius of a square, that means you need to remember what that is. The radius of the square goes from the center to the vertex is 8 root 2. Okay, find the measure of the central angle, the apothem, the perimeter, and the area of the square. All right, so let's look at all these pieces. So the central angle, remember that's all of these pieces, so 360 divided by 4. So each of the central angles is 90. Okay, so my central angle is 90 degrees. Then it asks for the apothem. So the apothem goes from the center perpendicular to the side. Well, if we look at this, we split that 90, that makes this 45 and 45. If you look on your formula chart, right, it was x root 2. Okay, so we have our x root 2 is on the hypotenuse, so that means that x is 8. So this is 8 and this is 8. So my apothem is 8. The perimeter, well, remember if we look at this little triangle right here, okay, that little triangle gets doubled and flipped on the other side, so that's also 8. So my perimeter, my side length will be 16. There are 4 of those, so my perimeter will be 64. So the area of the square, if we use 1/2 AP, it's 1/2 of the apothem times the side, or times the perimeter, which is 64. So we get that the area is 256. Now, y'all, let me just kind of back up and see what makes sense. Look, if this side length is 8, y'all, then this side length is 8, or is, excuse me, if that side is 16, then that side's 16. 16 times 16, if you use the side squared formula, then 16 times 16 is 256. Okay, don't overlook, if you're doing the harder version of these questions using 1/2 AP, don't forget that you do actually know how to find the area of a square. Okay, so given this hexagon, the apothem is 9 root 3. So you got to know what an apothem is. So I always draw it. You can draw it in any triangle, but I always draw it there. So that is 9 root 3. And it says to find the measure of the central angle, the radius, the perimeter, and the area of the regular hexagon. Okay, so the central angles. Okay, so these are my central angles again. If we take 360 and divide it by 6, then we get 60 and 60 and 60. Right, so those are all 60. So my central angle, my theta, is 60. Okay, then find the radius. So now let's resort down to this little triangle. We're just going to deal with it because remember we just cut that 60 in half. So that's 30, that's 90, that's also 60. Okay, again, go back to your 30, 60, 90 triangle. That's your long leg because it's across from the 60. That's 9 root 3. That means that x is 9, which is across from your 30, which means that your 2x, or your hypotenuse, is 18. So now I know that the radius is 18. So I'm asking for the perimeter. Well, if that piece is 9, then this piece is 9, which means that the whole side is 18. So it's 18 all the way around. So 18 times 6 is 108. So the perimeter is 108, and we want the area. So area is 1/2 the apothem, which was 9√3, don't forget that was given, times the perimeter, which is 108. So you would do all of the math, 1/2 of times 9 times 108, and you get 486, and then we're going to keep the √3, because that leaves it exact. So 108 times 9 divided by 2, you have 486. Okay, and then we didn't multiply the √3, so we just multiplied all of these pieces, and then we left the root the same. All right, so we have a wooden coaster that's a regular octagon with 3 centimeter sides and a radius of 3.92. Okay, so the radius goes from the vertex to the from the center to the vertex. That's 3.92. Okay, and then I want to know what's the area of the coaster. Well, I need 1/2 the apothem times the perimeter. So I need the apothem. So if we turn this and we draw in that apothem, here's what we're looking at. We have this little triangle, right? This is 3.92. This side is half of this side, 3. So that means this is 1.5. So the apothem, so this, let me highlight these so you can see, this matches this. Okay, this piece, 3.9, that matches 3.9 right here that they gave me. And the 1.5 came from half of the 3, because when I dropped down the apothem, it cut that in half. So we need to do Pythagorean theorem to find the apothem. So I have a squared plus b squared is equal to c squared. So 3.9 squared minus 1.5 squared. You get that a squared is 12.96. You take the square root of both sides. You get that a is 3.6. So remember, squared is undone with a square root. So I take the square root. So a is 3.6. So that's my apothem. Well, that's easy. So I have my area is 1/2 the apothem, 3.6, times the perimeter. Well, there are 1, 2, 3, 4, 5, 6, 7, 8. 8 sides that are 3 centimeters apiece, so that would be 24. We can mental math that. So if I do 12 times 3.6, and I get that the area is 43.2. The 12 was the 24 divided by 2. So I get centimeters squared. Find the apothem, find the perimeter, and you got to use right triangles. Okay, so you got to go back to those things that we learned, Pythagorean theorem, special rights, maybe even some trig that we're about to get into. Okay, so let's look at this. So we have a regular pentagon that has a radius of 6.8. It's a pentagon. Well, we need that central angle, so let's put in those central angles. Remember, the central angle for a pentagon is 72. Now, I need the apothem. It's the only way I know how to do this, right? So I have that apothem. So here's what I want to do so you can see it bigger. I'm going to take that little red triangle. I'm going to come over here and I'm going to make it a little bit bigger. So what happened when I drew that apothem in, I cut that angle in half, that 72-degree angle. So that means this angle is 36 degrees. Okay, the radius was 6.8, so I can put that there, right? That is this piece. This piece matches this piece. I just drew it over to the side so you could see it a little bit bigger. Well, I need the apothem, and I need the side length. Okay, so I'm going to call A and B. Now, notice you can't use Pythagorean theorem. We don't have any special triangles that involve 36. And when you see an angle that isn't a 30 or a 45 or a 60, it has to be trig. So to find, we have to use our SOHCAHTOA to find A and B. So my hypotenuse is 6.8. My opposite side is B, and my adjacent side is A. Okay, remember the goal. We need A and we need P. So I need the apothem. I need to find A, little a for the apothem, and I need to find B so that I can find the perimeter. So I find A, that's A and H, so the cosine of 36 is equal to the adjacent side divided by the hypotenuse. So if I multiply both sides by 6.8, so 6.8 times the cosine of 36, please make sure your calculators are in degrees, or it won't be right. We get that the A, or the apothem, is 5.5. Okay, we'll round it at the end. Then we use sine. So the sine of 36 is equal to B over 6.8. Multiply both sides by 6.8 to get rid of that and get B by itself. So 6.8 times the sine of 36, and you get 3.996, so that rounds to 4. Okay, we'll use 4. So that means this is 4. And this was 5.5, that piece. So remember that we need that rest of the triangle, so the whole side is 4, or 4 and 4, which is 8. So each of these sides is 8. Okay, so 1/2 the apothem, which was 5.5, times the perimeter, which would be 8 times 5, which is 40. So you take 20 times 5.5, and you get 110. So the area is 110 inches squared. Okay, so sometimes you need your right triangles, Pythagorean theorem, sometimes you need special rights, and sometimes you need trig. All of this comes back down to one itty-bitty little right triangle that we need to use. So you got to draw in that apothem, that radius, and the side length form that right triangle that we can use to find the apothem, so that we can find